Now in this video, we're going to look at a current mirror. So this isn't completely wired up yet. We're going to set the meter to measure milliamps of current. We want 1 milliamp of current. We just leave the red probe in that spot for everything except for high current. And so we got milliamps. We got to make sure that we don't measure more current than what we have the meter set to. So this side of the circuit is actually going to be the amount of current that we set. So I picked the resistor values that I picked so that we get 1 milliamp of current with a 5 volt power supply. Now I'm going to put this to the negative rail right there instead of going through the meter. Remember, the current has to go through the meter to measure it. And now we'll see that we have 1 milliamp of current going through the LED. Slightly different, but pretty much the current that we set. LEDs don't limit current. They just drop some voltage. And there we go to the collector of the transistor right there. And you can see that it's a tiny bit higher, but ultimately nothing is limiting current except for the transistor right there. And it's pretty much the current that we set over there. As you can see, it's slightly different though. And now we'll take a look at the schematic. So I'm using PNP bipolar junction transistors. I'm using the 2N3906. Doesn't really matter which one you use, but it might have a different pin layout if you use a different one. So flat sides are to the left. That means the left or the top pin there is the emitter, both to the positive supply. And then the bases we have tied together, but the transistor that we're going to use to set the current needs the base to collector right there tied together. So collector is the bottom pin right there. That is going to be our reference current. So based on how much current is flowing over here, it will set how much current it lets that one. And I don't have a good explanation why, but that is the way it is. So there you can see. And we already took the current measurements. I had to take the measurement before I put this to the rail because the current had to go through the meter. And we have to measure the current there. Once we know for sure we have just about 1 milliamp of current flowing through here, we can just put the jumper up there. And now this LED, as long as we have 5 volts at the supply, will just pass 1 milliamp of current, and we could adjust it in a way. We could also add more parallel transistors. We might run into some complication. That way we can use this to program how much all of them will pass. So you may find some complications that you have to deal with, but you know, that's a potential possibility. I did the math here with 4.4 volts because remember you drop about 0.6 volts and 4,410 ohms of resistance. That's what I have there. You get about 1 milliamp of current, and their values may have been slightly lower. That's why we might have got slightly more. These calculations are not perfect, but we did get pretty much spot on 1 milliamp according to the meter for the current that we set. Now when it came to the load, we saw we got slightly higher, but we were doing a lot better with this LED, which was dropping some of the current. So it looks like for this really to be effective, you still want some resistance or voltage drop or something. The transistor trying to do it by itself, remember we bridged around the LED and just went right to ground. We saw the current was higher and it was going up. What tells me is that as the transistor warms up, it's conducting better and you're going to get some more current right there. So we're still limiting current, you know, fairly well, but without any load at all, the transistor didn't do terribly great. We were like 25% higher at the end there. So you probably still want a certain amount of resistance there if you're going to set a a low current somewhere in a circuit. So I don't see this a lot. I do see it pop up from time to time in circuits, the current mirror. So for the most part, you probably won't find a good use for this, but you will see it if you look at a lot of schematics and you'll understand what it's doing at that point.